What I'm doing here? Well, I'm checking everything that I need to manufacture semiconductors. You're saying it's only sand? You're right. Maybe it's as simple as that, but we will find out together. It might not be as simple as that, for sure. It's complicated. But actually, it's true. I mean, sand is the beginning of everything in this case. What is the consequence? What are we doing with the sand? So the sand will be used to manufacture silicon. And silicon is something that we have here. It's some rather blackish, kind of initially dirty silicon with some byproducts as well, but it's silicon. So what do we do with it? It certainly undergoes a certain cleaning process afterwards. Then we will get polycrystalline silicon. The polycrystalline silicon is something that we will convert into a monocrystalline silicon. And that will certainly undergo a wafer manufacturing step, which will result in very thin slices of silicon. And in return, this will be masked, this will be etched, this will undergo a doping process in order to include different kinds of atoms into that. It will certainly undergo testing, packing, and finally, basically, we are creating the chips we need for our telephones, for our TVs, for whatever you need to go into any kind of IT communication base. But for a while now, let's get back to the sand and let's have a deeper look. What is sand actually? Sand is silicon dioxide. And when you think about it, what can you do with it? You can probably build a sandcastle out of it, but actually nothing more. Sand is very harmless. It's certainly not toxic. You can eat as much as you want. Finally, it's a very stable product. So why is it that stable? Because initially, when it has been created, it's coming from the elements. So when you think about, for example, of silicon and oxygen forming sand at some stage, you will end up at a very low energy level. And that's the reason why sand is so stable. In contrast, when you want to make the elements again, or let's say concentrate on silicon here, you would need to add a lot of energy into that process. The energy that you would need to add is roughly 10 megawatt hours per ton of silicon that you want to produce. And how do you do it? Well, it's actually kind of like steel production. So what you are doing is you are adding the oxidized product, so sand, together with carbon, with coal, with charcoal, and you will dump it basically into a Söderberg furnace in which you have carbon electrodes and you would ignite an electric arc in that, and undergoing different consecutive reactions, you will form with roughly 2000 degrees of Celsius an atmosphere in which the actual reductions and the actual reactions are taking place in order to form what we have here in hand. Again, this undergoes a cleaning step, etc., etc. Let it be this for now. If you have certain questions regarding that process, we would certainly be happy to get in contact with you about that and certainly about the consecutive reactions taking place. So far so good, stay healthy, and I would like to be very happy welcoming you in one of our next videos again. Take care.